All right, today we're going to talk about the one standard that really, truly put Wi-Fi on the map, IEEE 802.1b. I mean, this was the breakthrough. This is what brought wireless networking into our homes and offices. But, as we're about to see, its incredible success created a legacy that, well, network admins are still wrestling with even a quarter of a century later. Okay, let's get into it.
Now, just so you know, this explainer is actually part 3 of a big 20-part series we're doing for IT professionals. It's all based on a super detailed report on Wi-Fi and Bluetooth standards from the folks at RFI Detectives, who are part of Virtualization Options LLC. Today, we're zeroing in on Chapter 3 to really unpack the critical story of 802.11b. So, here's the big question, right? Before the year 2000, Wi-Fi was, well, it was barely on anyone's radar. It was slow, it was expensive, it was a total niche technology. So what happened? What was the spark that lit the fuse for the wireless revolution that we're all living in today? To really get why 802.1b was such a big deal, you first have to understand the wall it had to break through. See, when the original IEEE 802.11 standard came out back in '97, it had a major, and I mean major, speed problem. That's it. 2 megabits per second. And that was the absolute theoretical max. In the real world, you were getting even less. This was a huge roadblock. It was just way too slow to be a real alternative to plugging in an Ethernet cable, and so hardly anyone was using it. But then, just 2 years later, everything changed. In 1999, the IEEE ratified the 802.11b amendment. And this wasn't just some tiny update. This was the absolute game changer everyone had been waiting for. I mean, this timeline really tells the whole story, doesn't it? In just 2 short years, the standard rocketed from 2 megabits per second all the way up to 11. We're talking more than a 5-fold increase in raw speed. And that was the leap that made wireless networking not just possible, but actually practical. So how'd they pull that off? Well, the frequency band stayed the same, that good old 2.4 gigahertz band we all know. The secret was all in the physical layer. The modulation, the way the data is encoded onto the radio waves, got a serious upgrade. It went from things like direct sequence spread spectrum to a new, much more efficient version called high-rate DSS, which used something called complementary code keying, or CCK, to just cram more data into the signal. And that jump, that simple-looking jump from that little 2 Mbps bar to the 11 Mbps bar, that is what made 802.11b the very first commercially successful Wi-Fi standard. This was the moment Wi-Fi stopped being a lab experiment and started becoming a real technology for the rest of us. So if you remember one thing, remember this. HRDSS was the secret sauce. This smarter, more efficient way of encoding data was the key technological leap. It's what unlocked that 11 megabit per second speed and kicked off the entire Wi-Fi boom. But, the story doesn't end there. The wild, rapid success of 802.1b meant we built our entire wireless world on a foundation that, as it turned out, had a couple of pretty serious cracks that would cause problems for decades to come. The first big problem was security. The protocol that came with the standard was called Wired Equivalent Privacy, or WEP. And that name was, let's just say, very optimistic. It used a weak version of the RC4 cipher, and it had these static keys that nobody ever changed. It turned out you could crack it in just minutes. It was eventually discovered to be, and I'm quoting the source material here, catastrophically flawed. Now that web security flaw, that eventually got fixed with newer protocols like WPA. But the second problem? That one turned out to be much more subtle, and it's something that network professionals are still dealing with every single day. We're talking about the lingering performance legacy of this 25-year-old standard. Which brings us to a really important question for anyone managing a wireless network today. How is it possible that a protocol from 1999 can still be causing major headaches on your brand new Wi-Fi 6 network, or even a shiny new Wi-Fi 7 network running on 802.11b VHE? The answer all comes down to something called the legacy client performance penalty. You see, because Wi-Fi is a shared medium, everybody has to wait their turn to talk. And this means a single ancient 802.11b device can force your cutting-edge access point, one that's serving multi-gigabit Wi-Fi 7, that's 802.11be, clients, to slow way, way down to its level. So how does this actually play out? Well, first, there's the airtime fairness problem. A slow client takes forever to send its data, which means it's just hogging the shared airtime while all the fast clients have to wait. Second, to stay compatible, your AP might have to shut down modern features like wide channels, forcing everyone onto a narrow, slow lane. And finally, all the critical management traffic, like beacons, has to be sent out at the slowest possible speed, just so the old devices can hear it. And that just wastes precious airtime for everyone.
This quote from the RFI Detectives report just nails it perfectly. The AP must accommodate the slowest client's capabilities. That's the fundamental challenge right there. The entire network is basically held hostage by its slowest, least capable member.
So, here's the bottom line. 802.11b was the hero that made Wi-Fi a reality for all of us, but its success created this ghost that still haunts our modern networks, dragging down performance. And this leaves every network admin out there with a really tough choice. Do you keep supporting that one ancient device at the cost of everyone else's performance? Or is it finally time to go into your settings, disable those legacy data rates, and say goodbye to 802.11b for good?